Hey guys, and welcome to our animated walkthrough of LeetCode 75 SortColors. This problem requires us to sort an array of size n containing 3 different elements. To tackle this challenge, we're going to explore the Dutch national flag algorithm proposed by Edgar Dijkstra. You might already be familiar with the name Dijkstra, as another algorithm, Dijkstra's algorithm, is widely used in finding the shortest path between nodes in a weighted graph. I'll probably make a video on that in the future, but for now let's focus on the Dutch national flag algorithm. This problem is particularly interesting for designing sorting algorithms, especially as it plays a crucial role in enhancing variance to the quicksort algorithm. Quicksort needs to be robust, especially when dealing with repeat elements. This is where three-way partitioning comes into play, grouping items less than a given key red, equal to the key white, and greater than the key blue. To kick this video off, let's take a look at the algorithm in action without delving into how it works. One thing you may notice is that the algorithm appears to sort from the outside in and also from left to right. Let's reset the array and take another look. Now let's break down the Dutch national flag algorithm. First, we initialize 3 pointers. Low and mid are set to the start of the array, and high is set to the end of the array. Think of these pointers as markers that will help us sort the array. We then begin iterating through the array. The iteration continues as long as the mid pointer is less than or equal to the high pointer. During each iteration, we look at the value of the element at the mid pointer. If it's 0, we swap it with the element at the low pointer, and then increment both the low and mid. This effectively moves all the zeros to the beginning of the array. If the element at mid is 1, we simply move the mid pointer forward. We're leaving all the 1s in the middle. However, if the element is 2, we swap it with the element at the high pointer, and then de-increment the high. This moves all the 2s towards the end. We continue this process until mid surpasses high. At this point, all elements are sorted, all 0s at the start, all 1s in the middle, and all 2s at the end of the array. Let's now look at an example from LeetCode. We're given the input array 2, 0, 2, 1, 1, 0. We'll start off by initializing our low and mid pointers at the beginning and our high pointer at the end. We will also keep track of mid up at the top. We can see initially that mid is pointing to 2, which means we swap it with the element at high and de-increment high by 1. This leaves us with mid pointing to 0. In this case, we normally swap low and mid and then increment them both, but since they're both at the same index, we can skip the swap and simply increment. The same is true for the next iteration, so we can simply increment again, leaving us with mid pointing to 2. The same as before, we swap the element at mid with the element at high and de-increment high by 1. Now with the mid pointer pointing to 1, we increment it by 1. The same is true again, in which case we increment again, breaking the loop and leaving us with the sorted array. Okay, let's code this up in Python. One take. Let's see if I can get it. Okay, so we're going to start with initializing our variables, low, mid, and high. These are going to be equal to 0, 0, and the length nums -1. Let's clean that up. Okay, so we're going to go while mid, not miss, mid is less than or equal to high. Now we have if. It's going to be nums of mid. So we have 3 cases. Just the first one really. If it's equal to 0, we swap nums of mid and nums of low. So nums mid is going to nums mid and nums low. So this is just how we swap in Python. Nice and simple. Low and then nums mid. Okay. Then we have to increment them both, so we do low plus equals 1 and mid plus equals 1. Now, not plus equals q. Now our next case is going to be, it's like an elif, nums of mid is equal to 1. Sorry, you might be able to hear my dog in the background. Mid is plus equal 1. So in this case, we're just incrementing, right? Like here we're, if mid is equal to 0, we want to swap mid and low so that we push essentially all the zeros to the back or to the left side, and then we increment low, which means that anything to the left of low is going to be a 0. Here we're just keeping the 1s in the middle, so we're just incrementing by 1, and then our last case is going to be else And in this case, it's when nums is equal to, or sorry, nums of mid is equal to 2. So for that, we do nums of mid and nums of high, and that's going to be equal to nums. We're just swapping them, right? So nums high and nums mid. And in this case, because we're pushing essentially the 2 over to the right where high is, and then we want everything to the right of high to be a 2, so we're de-incrementing high by 1. So it's going to be a minus equals 1. Let's see, submit. And yeah, there we go, no mistakes. 98%, not bad. Like I said earlier in the video, I think this runs an O of n time complexity, and it's constant memory. So yeah, thanks for watching.